Good afternoon. This is Schweitzer, and we're doing a little practice quiz here. So, if you can do this, then you can do you should be able to do the quiz on our second quiz for acids and bases. So, take a quick moment and pause the video. Try it out. Should take you about 5-7 minutes. All right. Go ahead, pause. All right, so here are the answers for this particular quiz. So first of all, first question, usually it's going to come out here is a little bit of the first stuff. Determine the pH of a zero point 0.4 molar HNO3. Now, first things first, we start doing a whole bunch of these calculations, and people get a little bit obsessed with them a little bit. So what happens is in class is I'll have a kid come up to me and very panicked saying, "Oh, Mr. Schweitzer, I need the Ka for this particular acid. You didn't provide it for us." And I would be like, "Okay, it doesn't have a Ka," and that's because strong acids are so strong, the Kas are so big. Essentially, we're going to completion, and we treat them just like stoichiometry. So only weak acids have a Ka, and we don't need to do anything else with this because it's not a weak acid. So essentially, all we gotta do for a strong acid is negative log of the pH, which is zero point 0.4, and there we go. So do the math. So don't get too caught up in this. Negative log 0.4, 0.397, and we're done. Okay. Now the weak acid calculations, although at first they seem kind of litigious or a lot of little moving parts. That's true. But for the most part, the process never changes. So you could put an example of this process on your note card and you'd be good as golden if you don't maybe remember it or want to memorize it. But there are some underlying ideas here that are more important than just this calculation. And the idea here is that a weak acid um, goes to equilibrium, where a strong acid goes to completion. So let's take a moment here and just write out the hydrolysis reaction for jacksonic acid, okay, named after a very famous science teacher called, well, Mrs. Jackson. All right, so JHJK plus H2O yields, and I'm going to put a backwards arrow here just to make myself feel good, H3O plus JK minus. Okay. Initial stoic ratio end. This is 0.4. Not playing a role because it's a liquid. 0, 0 minus x plus x. Again, after you do 2 or 3 of these, you'll realize that this process is the same every time, which is sometimes a problem that people start doing the strong acids. They forget to turn off that process. You got to understand what you're working with. So my Ka in this situation is equal to x squared, x times x, I'll just leave it at that, that's x squared, over 0.4 minus x, okay? So I'm going to utilize my shortcut rule here, and I'll just rewrite this thing. So the Ka is 1.6 e to the negative fifth equals x squared and 0.4. I used my shortcut rule there. Okay, multiply by 0.4, square root, and what does x equal? Okay, 1.6 e to the negative fifth, got that, times 0.4, and I'm going to square root this value. And I got 0.0025. So 0.0025. That's moles per liter of H plus ions. So this, on a test, this would really be worth 1 point. The rest of this stuff is just a data table. That'd be worth a point. And this would be worth a point. Taking that value, negative log of the 0.0025 and then gives me my pH. I know that we teeter-totter on this guy here, 1.0 e to the -7th, and therefore my H pluses have gone way up, and my hydroxides have gone way down. So even though this is a weak acid, there's no other base to compete with. So all it has is this. Be like saying you're the toughest kindergartner on the block when all you have is 4Kers. But in this sense, it's a weak acid. Okay, so it's producing an acid. So I'm going to take the negative log of the previous answer, and I get 5.97. So not horribly strong. 5.97 is the answer to that. And this would be the second point. All right, our last question here is, you have a 0.4 molar concentration of schweitzic acid. Has a Ka value of 1.96 e negative sixth. Is it stronger, weaker, or the same strength as the acid? So in order to determine the pH that an actual acid will produce, you'll have to have two factors that you would be used. We use them both up here. One, we use the concentration, and one, which is located here, and one is the K value, and that's it. Given these two values, you could determine whatever you want. So this is the concentration. The concentration is one thing we need, but the other thing we need is the Ka value, and that is referred to as the strength. That's kind of like how much you get at once, and how product favored are we getting. Of the point where we have, what fraction do we actually get? How much do we get? Okay, so this is a pretty simple question. My answer is this Ka bigger or smaller than this Ka? And because -6 is smaller than -5, this thing is a weaker acid. So a little bit of thought here, and hopefully fared well. Thank you very much.